This is Mrs. Appia with Lesson 8, Module 4. Student outcomes for this lesson. Given the exact value of a quantity and an approximate, estimated, or measured value of the quantity, students compute percent error. Students understand the meaning of percent error as the percent the absolute error is of the exact value. We'll write this down in your summary at the end. The absolute error is the difference between the exact value and the measured value. The absolute error is the approximate amount minus the exact amount. Other words that might be used instead of approximate might be the estimate or the measure. The percent error is the percent the absolute error is of the exact value. So there's a formula that you can use to calculate the percent error. And the percent error is equal to the absolute value of the approximate minus the exact amount divided by the exact amount. That's going to give you a decimal. To convert it to a percent, you multiply it by 100. So the absolute error is just the difference between the right answer and the wrong answer. The percent error is when they compare the amount of the error to the right answer. So two different things. Pause the video and copy the essential question. What is the formula for percent error? So on the first page in the example, how far off, we're going to calculate the absolute error. Explain what the absolute error means in the context of the problem. So I want you to take a look at this TV. And you think some people have a 32-inch TV, a 20-inch TV, a 50-inch TV. Think, how is that measured? Is it measured up and down? Is it measured left to right? Is it measured on the diagonal? Well, TVs are measured on the diagonal of the screen. So what they did is they had Taylor, Connor, and Jordan measure this TV. And what they noticed is that they all came up with different answers. Not only did they come up with different answers, but they measured it twice and still came up. When Taylor measured it, she came up with two different answers. So obviously there's an error here somewhere. So what we're going to do is calculate the absolute error. The absolute error is the absolute value of the difference of the approximate value minus the exact amount. Now the reason we use absolute value is because we're not concerned if the answer is overestimated or underestimated. We just want to know how far off it is. So in this example, the exact amount is 15 inches. And we know it's 15 inches because that is what it says on the box from the people who made the TV. So the approximate amount is 15 2/8 inch. When you subtract that, you get 2/8. And the absolute value of 2/8 is 2/8. Remember that absolute value will always be a positive number. Absolute value is the distance from 0. You can simplify that if you want to. You would write 1/4, or you could write it as a decimal 0.25. Any of those would be acceptable. So what this means is that Taylor's measurement is 1/4 inch off the actual amount. Connor's measurement. So we want the absolute value of the approximate minus the exact. So his approximation was 15 4/8. The exact amount is 15. So subtract those and you get 4/8. And the absolute value of 4/8 is 4/8. And you could simplify that if you wanted to, or you could even write it as a decimal. So what that means is Connor's measurement is 1/2 inch off the actual amount. So we have Jordan's measurement, and this is Jordan's second measurement. So our formula for absolute error is the absolute value difference of the estimated amount, which is 14 6/8 minus 15. So when you subtract that, you get a negative 2/8. Now you want the absolute value of that. So negative 2/8 is how far from 0? It is 2/8 from 0. So it is a positive number. You can simplify that if you like. What this means is Jordan's measurement was underestimated by a 1/4 inch. And Connor's measurement was overestimated by a 1/2 inch, and Taylor's measurement was overestimated by a 1/4 inch. So we're not really concerned whether it was overestimated or underestimated, just how far off was it. In our next section, how right is wrong, we're going to find the percent error for Taylor's measurement. What does it mean? The formula for percent error is percent error equals, and you can see that it's the absolute value of the approximate minus the exact, which is what we just did on the previous page. So this top part of the formula represents the absolute error. In other words, how wrong were you? So we have the absolute value of 15 2/8 minus 15 all over the exact amount of 15. Notice that the exact amount gets used in the formula twice. And we're going to multiply that by 100 to convert it to a percent. So the difference is 2/8 over 15 times 100. And when you calculate that, your answer is 1.6 repeating. And 1.6 repeating is 1 2/3%. A small percent like this means that the estimate or the measurement was very close. From example 1, part B, find the percent error for Connor's measurement 1. So Connor's measurement was 14 4/8. The percent error is equal to the absolute error over the exact. It helps if you write the formula each time you use it. That will help you to memorize it. Notice again that the exact amount is in the formula twice. So the approximate amount was 15 4/8. The exact amount was 15. We want the absolute value of that. And we're going to divide that by 15, the exact measurement. So that gives us 4/8 divided by 15 times 100. And when you calculate that answer, you will get 3 1/3%. You get 3.3 repeating. So you can use your ABC or your second FD button to convert that. So 3.3 repeating is 3 1/3%. 3 1/3%. So who was more right? Taylor was more right. Taylor was closer to the exact amount. Okay, so we're going to go on to question G here. What is the purpose of finding the percent error? So just think about this. An error of 1 centimeter is very small when measuring the distance of a marathon, which is 26 miles. But an error of 1 centimeter is very large if you are a heart surgeon. So percent error is useful because it tells you how big your error is compared to the true value. And it gives you a more accurate number to tell you how close you were to the right answer. All right, we're going to go ahead now and we'll just keep going all the way to the summary. Now in the summary, the absolute error is the magnitude of the difference. So it's a number value between the approximate value and the exact value. Remember that the approximate value could be a measured value or it could be an estimated value and the exact value. It tells you how far away in units the approximate value is from the exact value. Percent error is the percent that absolute error is of the exact value. So if you were thinking about this in terms of the quantity and the whole, then the difference here, this would be the quantity, and the actual amount would be the whole. and the percent error is what you're looking for. So again, you're comparing a quantity to a whole through percent.